Okay, so welcome to the 11th class of computer architecture and organization. Okay, so in the previous class we have discussed about end instructions and or instructions, isn't it or not? So we have discussed about end instructions and or instructions. So these all will come under the all the end and or instructions will come under the category of logical instructions. Okay, so now in this class we are going to discuss about different types of shift operations. Okay, so different types of shift operations. Whatever the operations we are going to learn in this class, all those same instructions will be present in our MPMC, microprocessor and microcontrollers, in our next semester. Okay, and the same instructions with a little bit of modification, they may be present in our PIC microcontroller. And whenever, see, I am specifying the same thing, that when if you want to opt embedded systems ES as your branch, or if you want to do any research, that means if you want to go to the core side of our companies with embedded systems, okay, then obviously these things will be very much helpful, because you need to write a program in order to develop any component. Okay, so for that you need to write a program. The instructions of a program varies from processor to processor and controller to controller. Okay, that means if I am writing the program by using some 8086 microprocessor, the instructions are different compared to the instructions that are present in a 8051 microcontroller, and they may be different compared to the instructions in a PIC microcontroller. Okay, so like this, the instructions will vary from processor to processor and controller to controller, and the programming style may vary, but the basics won't change. That means there also here whenever I use an instruction A and D, instead of A and D, it may be A and L, like that. There will be a little bit of modification. So if you are much more aware about the basics, then obviously you can easily score, or obviously you can understand any programming language. That means either it may be 8086 or 8051, either it may be PIC, ARM, whatever it may be. So you can easily understand any language once if you are thorough, or if you have a knowledge on the basic instruction set. Okay, in the last class we have discussed about end instructions and OR instructions. Now we are moving to the next instructions, that is mean by, so the next instructions are shift instructions. Okay, here in the shift instructions we are going to shift the data from one side to another side. Okay, so here we are going to shift the data. That means we may shift the data from left to right or from right to left. Like that we can do the operations. So that is the purpose of this shift instruction. Okay, so shift instructions are generally classified into two types. First one is logic shift, and the other one is arithmetic shift. First one is logic shift, and the other one is arithmetic shift. Shifting is nothing but moving of the bits in a particular register, either from right to left or left to right. Okay, so that means I may move the bits from left side to right side, or from right side to left side. Once if I explain you with the example, then you can get a good idea. Okay, so actually initially the shift instructions are classified into two types. First one is logic shift, and the second one is arithmetic shift. So what is the difference between these two things? Now we are going to discuss. Okay, before going to this topic, I think you have already a basic idea about what is meant by MSB and what is meant by LSB. LSB means least significant bit, and MSB means most significant bit. That's I will give a brief introduction about the terms. See, logical and arithmetical shift right. Before discussing this topic, see here you can observe some boxes from 1, 2, 3, 4, 5, 6, 7, 8. 8 small boxes are present with different binary numbers placed in it. Okay, so all together these 8 boxes all together is called as a register. Okay, it is called as a register. What is a register? Group of flip-flops is called as a register. This definition will come in your STLD subject. Okay, next. So a register is nothing but a group of flip-flops. Okay, it is well and good. What is the flip-flop? Flip-flop is a single bit binary data storage device. A flip-flop is a single bit binary data storage device. Okay, what is mean by binary data? Either it may be 0 or 1. So binary means either 0 or 1. Okay. Flip-flop is a binary data storage device. That means it can store either 0 or 1. Okay. Group of flip-flops is called as a register. Group of flip-flops is called as a register. Okay. So based on number of flip-flops that are present, that determines the size of the register. If you are having 8 flip-flops, then it will be called as 8-bit register. If you are having 16 flip-flops, then it is called 16-bit register. If you are having 32 flip-flops that are arranged in a sequence or serial manner, then it will be called as 32-bit register. Okay. Here in our example, we are having 8-bit register. Okay, because we are having 8 flip-flops. So flip-flop is nothing but single-bit binary data storage. Here, if you observe, ones and zeros are placed in each and every box. So everyone is a everything is a flip-flop. So here we are having 8 flip-flops. Okay, that is one concept. And for every number or for every register, whatever you call, there will be 2 bits. One is LSB bit and the other one is MSB bit. LSB means least significant bit. What does it mean? Least significant bit. The bit that is present in the rightmost side or the starting bit from the right side. So if you observe here, what will be the starting bit from the right side here? This one, isn't it? It is indicated with some arrow mark or something now. It will be called as least significant bit, LSB. Okay, na? And the bit that is present in the leftmost side, it will be referred as MSB, most significant bit. Okay, the bit that is present in the rightmost side, that means the last bit that is present at the rightmost side is called least significant bit, and the bit that is present in the leftmost side is called most significant bit. Like that, we are having a least significant bit and the most significant bit. Okay, so this is the thing you have to learn. Okay, next, what we are going to discuss now is right shift. What is the shift we are going to discuss? Right shift. And if you observe here, there are 2 types of right shifts. One is spotlight. Okay. Here we are having 2 types of right shifts. What are the 2 types of right shifts? One is logical right shift, and the second one is arithmetical right shift. See, if you observe here, we are having 2 shifts: shift right logical and shift right arithmetic. What is the difference between these 2? Okay, so here if you observe, this topmost bit will be called as sign bit or MSB bit. The other name for this topmost bit is sign bit or MSB bit. Okay, see, for example, I have 8 bits like this: 1010, 0, 111. Okay, whenever I perform shift right operation, that means what is the thing that is going to happen? The data has to be shifted to the right side. That means whatever the value that is present in the one in the MSB, that will be shifted to the next right position. That means this one will be appearing here, and whatever the 0 that is present here, it is going to shift to the next position. Whatever the 1 that is present here, it is going to shift to this position. Whatever the 0 that is present here, it is going to shift to this position. You can observe by using these arrow marks. Okay, the 1 that is present here, it is going to be appeared in the next location. Okay, the 0 is going to shift from here to here. The 1 is going to shift from here to here. The 0 is going to shift from here to here, and the 0 is going to shift from here to here. And the 1 that is present here, it is going to be shifted from here to here, like that. Then what happens? See, this 1 is going to shift to here. Then what happens to the 1 that is already present here? Okay, that is the thing now. It will be left to the somewhere. It will just come out from that particular register. Where it goes, we don't know. Or simply to say, whenever there is any carry flag, okay, there is a flag called carry flag. Okay, these flags indicates the status. A number of flags will vary from processor to processor and controller to controller. These are all the things you will learn further in the next chapters, or if not in our CAO, you can learn even microprocessor first year. Okay, as of now, what is the thing you have to understand means whatever the last bit, which is called as LSB bit, that is present whenever you are performing shift right operation, whether it may be logical shift right or arithmetic shift right, whenever you are performing this operation, the last bit is going to be coming out from this particular one, from this particular register, and it will be escaped to outside world. Where it goes means we don't bother. Okay, but one thing I can give clarity, it won't come again into this flip flop. Okay, whatever the bit that is escaping, or whatever the bit that is coming out from this particular LSB position, it won't, there is no chance of again entering that particular bit via this channel, via any into this register via any channel. There is no such kind of possibility. Once it is coming out from here, it may go to the carry flag. Afterwards it may escape to somewhere where we don't know, we don't bother also. Okay, so if you observe here, okay, so I have told this one will come to here, this 0 will come to here, this one will come to here, that you can observe by using this arrow marks. Then what happens to this first position, which is going to become empty, because the one that is present here, it is going from here to here, isn't it or not? That means here you will get a empty position. So how this empty position is going to be filled? It is going to be filled with 0. It is going to be filled with 0. Is it okay? How many times you made? That means you are nowhere bothered about this previous bit value in that particular location. Whenever you perform this shift, okay, whenever you get an empty place, that is going to be filled with 0. That means if I want to perform the right operation, shift right logical operation once again, then this 0 will come to this place, this one will come to this place, 0, 1, and this 0 will come here, this 0, this one will go to the outside world. Okay, here also you will get an empty place in the first position. Okay, how it is going to be filled means that is going to be filled with 0. That is going to be filled with 0. 1 minute. And wait, by using text. So now what we are going to get? 0. So this 0, what is there here? It is going to, the 0 what is present here, it is going to come to the next bit position. Okay, next here, what is the thing? It is going next bit 1. Next again, what we are going to get? 0, 1, afterwards 0, again next 1, 0, 0, 1, 1. Okay, sorry, 0, 0, 1. That means this 0 will come to this position, this one will come to this position, and this 0 will come to this position, this 0, this one here, and this 0 here, this 0 will come to here, this one here. So that's what I have written. The last one will be, it will come out from this particular register. Isn't it or not? Okay, then what is the thing that is going to happen means I will get a empty first position. Isn't it or not? The first position is going to be empty. So with which I have to fill that particular first position means whenever I perform logical shift operations, observe carefully, whenever I perform shift, this is only for right. Whenever I perform logical shift right operation, okay, the empty place that is present in the MSB or topmost left side, it will be obviously filled with 0. It will be obviously filled with 0. That means this is the answer what we are going to get. Okay, if I perform this operation, that means if I perform this shift once again, okay, then what I am going to get means, see, this first 0 is going to be occupied by occupies the second position. Later on, the second bit is going to be occupied by next position, next 1, 0, 1, 0, 0. Okay, that means here there is an empty first position. Isn't it or not? There is an empty first position with which I have to fill means that empty first position is going to be filled by default with 0. Okay, so this is the resultant sequence what we will get after shifting the previous value. If you perform shift right logical, that means logical shift right. Okay, so this is the thing that is going to be repeating. Okay, so take this as an example of if you do the shift right again, so first position is going to be empty, 0, 0, 0. Next 0, 0, 0, 1, 0, 1, 1, 0, 1. Isn't it done? again 0. The last 0 is going to be coming out from there. So what about the position of the first place? Again it is going to be replaced with 0. Okay, so this thing is going to repeat again and again. This is about shift right logical, that means logic shift right, simply to say logical shift right. I think you are very much clear. Okay, next we are going to discuss about arithmetical shift right or shift right arithmetic, which will be generally called as shift right arithmetic. Shift right arithmetic. So what is the difference between these two things? Previously we have discussed about shift right logical, that means logical shift right. Now we are going to discuss about shift right arithmetic. See, if you observe, there is only one difference. What is the difference means? Whenever we are shifting the data to the right side, okay, you are getting an empty place in the leftmost bit, which will be called as MSB bit, which will be called as MSB bit, isn't it or not? So you are getting an empty place in this particular leftmost bit, which will be generally referred as most significant bit. Okay, previously what we have done, whenever we are shifting the data, whenever you are getting empty MSB bit, we are going to replace it with 0. We are going to replace it with 0, isn't it or not? So, but whenever you are performing shift right arithmetic operation, whenever we are going to perform this shift right operation, there is only one difference. What is the difference means? See, this topmost MSB bit is there now. There is another name for this topmost MSB bit. It is also called as a sign bit. It is also called as sign bit. Very important topic. Okay. So whenever I perform arithmetic shift right, the same thing is going to be repeated, but except only one difference. What is the difference means? See, here if you observe, initially this one is going to shift from here to here. That means I will write the value. See, consider this as an example. Whenever I perform a shift right, what is the thing that is going to happen? This one will come to the second position. Afterwards, 0, 1, 0, 0, 3, 1. Okay, and you will get a empty place in the first position. Okay, in the previous class, that means whenever you discussed about logical shift right, what we have done? We have just placed the 0 in this particular first bit, or MSB bit, or sign bit. Okay, but here there is a small variation. What is the variation? Means we have to fill this particular location with the value what that is present actually before the shift operation. That means this is the original value now. Okay, after shifting you have got this value and you have to fill the MSB position or sign position. Okay, with which you are going to fill means you have to fill it with the value which is actually present there before the shifting. That means this is the original value. Before the shifting, what is the value that is present here? 1. If here if anyway 0 is present, you have to replace the first position with 0. Here it is 1, so you have to replace the first position with 1. That means whenever if it starts with 1, every time whenever the first position becomes empty, it is to be replaced with 1 only. Okay, if it starts with 0, then it should be replaced with 0 only. But in the previous case, no such kind of things. Whether it is 1 or 0, I don't bother. I will replace the MSB bit with 0 only. Clear concept? So here also, whenever I perform the shift operation, then what is going to happen in the next place? So here 1 1 0 1 0 0 1 1. This is the thing we are going to get, because I have already discussed that the last value is going to be escaped to somewhere else. Generally it will go to the carry. At present instant of time we don't have any idea about carry now, so you just leave it. It will go to somewhere where we don't know. We don't bother. Okay, so this is the position that was left unused. So it should be with which value it is going to be filled means before shifting what is the value that is present in this particular position? 1, isn't it or not? So that 1 is going to be replaced again. Okay, I think you are very much clear. Next, if I want to perform shift once again, so what is the value that is going to appear once again? See, if I want to perform the shift once again, then what I'm going to get? 1 1 1 0 1 0 0 1. Okay, Here I have again empty place. With what it has to be filled? It should be filled with 1. Okay. So this is the value that is to be replaced with. Okay, like this we are going to do the we are going to perform this shift right arithmetic or arithmetic shift right operation. Is it clear? Okay, next we are moving to the next slide. Yeah. Next, see, in shift left there is no arithmetic and logic. We are having only one shift left. Either you use arithmetic or logic, both are going to perform the same thing. So there is no arithmetic shift left operation. There is only normal shift left operation. Okay, shift left operation is very much similar to logical shift left operation is very much similar to logical shift right operation, except one change. What is the change? You all are very much know that in the shift right operation, the value is going to shift from left side to right side. In shift left, it is going to shift from left side left side from where to where it is going to shift. It is going to shift to the left side from your right side. Previously, from left to right, the value has shifted, but now from left it is going to shift to the right side. Sorry, from right it is going to shift to the left side. Okay, so if you observe here, or I will show you the difference. In the previous slide, if you observe here, the data is going to shift from this side to this side. But once if you observe here, the data will shift from what do you call right side to left side. Okay, so initially this is the value that is present, 111000101. Whenever I perform shift left operation, so then what it is going to happen? This one is going to shift to here, this one is going to shift here, this one to here, 0, 1. I think, okay, 1 minute. These are not erasing now. Where is the eraser? I know it. Erase. Yeah. Okay. So the value that is present, if the one that is present here, it is going to shift here. This one here, 1, 0, 0, 1, 0, and this one will come out of this register. This one will come out of the register. It will go to somewhere where we don't bother. So we'll get an empty place here. So with which it is going to be filled means it is going to be filled with 0. So how many times you perform this logic shift left operation, you will get every time you will get what you will get? You will get empty place in the rightmost side, which is called as LSB bit, least significant bit. That particular least significant bit is going to be overwritten with 0. It is going to be replaced with 0. Okay, if you observe here, I haven't mentioned any logical or arithmetical shift left operation. There is no arithmetical shift left operation. There is only logical shift left operation that is present. Okay, this you need to keep in mind. Okay, next we are going to the other operations called rotate operations. Okay, rotation. What is meant by rotation? So what are the best examples, or what are the examples of the devices which performs rotation? Rotation means moving in a 360-degree angle. Okay, so Earth revolves around, Earth can make rotations, isn't it, Anand? Does Earth makes any rotations? Yes, it rotates. Next, if you observe any bike, we are having two tires. The tires are going to rotate in order to move our vehicle. Okay, similarly bus tires, whatever it may be, and our clock is going to rotate. Okay, rotating means circular motion. That means moving of an object in a circular space, circular direction is referred as a rotation. Okay, then first of all we need to discuss why we came to these rotate operations. Okay, see, if you observe shift operations, whether it may be right shift or left shift or arithmetic shift or logic shift, whatever the operations if you observe, see, we have previously discussed now. See this one, whenever I perform right shift operation, this bit is going to become empty. It is going to be replaced with 0 whenever I perform logical shift right. Isn't it or not? And whenever I perform the bit that is present in the least significant LSB bit is there now. Where it is going? I have told it is going to carry, or afterwards that the bit in the carry, it will escape to somewhere in that place, in the total memory, somewhere it will go where we cannot identify. That means what is the thing that is going to happen means here we are losing the original bits or original information bits or original data bits. Here we are losing the original bits. That is the main drawback. Okay. So in order to overcome from this drawback, what we are doing, we are going to moving to the next concept called rotate operations. We are going to the next concept called rotate operations. Okay. So what is the major difference between shift and rotate operations? Okay. In the shift operations, if you observe carefully, the bits are missing. We are not getting those bits. Okay. We are missing the bits either from the MSB side or LSB side. Okay, whenever you are performing any shift operations, shift right operations, then we are missing the bits from the LSB, that means right side. Whenever you are performing shift left operations, we are missing the bits from the MSB side. That means altogether the original information bits are being missed and they are either replaced by zeros or ones, depending upon the type of the instruction what we have used. Okay, if it is logic instruction, they are replacing with zeros. If it is any logical expression, those are going to be replaced with the value that is present in the sign bit, either zeros or ones. In order to overcome from this problem, what is the problem? The original bits are being missed. Okay, so that particular problem can be overcome by using these rotate instructions. Here, whatever the bits that are present, they are going to be move in a circular manner. Okay, so that no bit is going to be missed. Okay, simply to say, shift operations ante entante bench unama, bench lo 5 unnaru, kottaga okadu వచ్చి ఏం చేస్తాడు, వాడు కొంచెం బలంగా ఉన్నాడు, ఒకవైపు నుండి తోసేసి వాడు కూర్చున్నప్పుడు ఏమైంది, ఆ బెంచ్ కెపాసిటీ ఓన్లీ 5 మెంబర్సే. ఓకేనా, ఆ బెంచ్ కెపాసిటీ ఎంతమ్మా, 5 మెంబర్సే. ఇప్పుడు కొత్తగా ఒకడు వచ్చాడు, ఇంకో వైపు ఖాళీ ఉందిగా. సో ఏమైంది, బెంచ్ అంటే రెండు వైపులా నీకు ఓపెనింగ్స్ ఉంటాయిగా. సో ఒకవైపు నుండి ఒకడు గట్టిగా వచ్చి కూర్చున్నాడు, పుష్ చేసేసి మిగతా వాళ్ళని, అప్పుడు ఏమవుతాడు, ఆటోమేటిక్ గా అటు చివరి ఉన్నాడు, కింద పడిపోతాడు, అంతే కదా. సో వీడి ప్లేస్ ని ఆక్యుపై చేసేసుకుంటాడు, అవునా, లెఫ్ట్ సైడ్ కూడా. ఓకే, సో నీకు షిఫ్ట్ ఆపరేషన్ అంటే అలా ఉంటది అనమాట. ఎందుకు, దానికి రిజిస్టర్ కి రెండు సైడ్లు కూడా ఓపెన్ గానే ఉంటది. ఒకడు వచ్చి కూర్చున్నాడంటే అక్కడ అటు సైడ్ ఆపోజిట్ సైడ్ లో ఉన్నాడు, ఖచ్చితంగా వెళ్ళిపోవాల్సిందే, లేకపోతే ప్లేస్ సరిపోదు. కానీ whenever you observe these rotate operations, okay, ఇక్కడ కొత్తగా బయట నుండి ఎవ్వరు రారు. Nobody is going to come from the outside. This is the main thing what you need to observe. Okay, in the rotate operations are nothing just like musical chairs. Okay, rotation అంటే ఏంటంటే ఒక 5 కుర్చీలు నేను లోపల 5 కుర్చీలు నేను ఇలా సర్క్యులర్ మేనర్ లో వేసా, 5గురే ఉన్నారు నా దగ్గర. మ్యూజికల్ చైర్స్ లో అయితే ఒక పర్సన్ ఎక్కువ ఉంటాడు, బట్ as per my concept of view, I have only 5 persons. ఓకేనా, వాళ్ళు ఎంత షిఫ్ట్ అయినా ఆ 5 persons వాళ్ళ పొజిషన్స్ మారుతారు తప్పితే కొత్తోడు ఎవడు రాడుగా, ఉన్నోళ్ళు ఎవరు బయటికి పోరుగా. సో దట్ ఈస్ ద బేసిక్ డిఫరెన్స్ బిట్వీన్ షిఫ్ట్ అండ్ rotate operations. Rotate operations is nothing but if you arrange 5 chairs in a circular manner and you are having 5 persons seated in different positions. Okay, whenever they shift, they may shift their positions, but any of those 5 persons may not go to outside, and any person from the outside he will not enter to the inside. So that is the main advantage of rotate operations compared to the shift operations. Okay, so there are 4 types of rotate operations. First one is rotate left without carry. Here with carry and without carry are the two instructions. Okay, so rotate left without carry, rotate right without carry, rotate right with carry or through carry it will be called as, and rotate left with carry. So left, right, with carry, without carry. So altogether there are 4 combinations. Rotate left without carry, rotate right without carry, rotate left with carry, rotate right with carry. Okay, so these are the 4 types of rotate instructions. So I have written spelling mistake here. ROTATE, rotate instructions. Okay, so now we are going to discuss these rotate instructions one by one. 1 minute. Okay, so we are going to discuss these 4 types of rotate instructions. Okay, so one by one. See, with this example, you can get easy idea of what is meant by rotate left, rotate right, rotate left with carry, and rotate right with carry. Okay, see, the first instruction is RL, that means rotate left. If you don't mention anything, see here, that means rotate left without carry. What does it mean? Rotate left without carry. Okay, if I mention here like this RLC, that means rotate left with carry. Okay, similarly here if you observe here, what is just mentioned here, RR, that means rotate right without carry. But if you observe here RRC, that means rotate right with carry. That means whenever there is a C that is present, that indicates there is a carry. If not, it indicates that there is no carry. Okay, with this slide you can easily understand the difference between these 4 things. Okay, for example, initially I have this data 100 11100. Okay, 1 minute, no, 8 text. Okay, here here okay, initially, for example, consider initially I have this data. What is the data I have? Initially what he has mentioned, 1 0 0 1 1 1 0 0. This is the initial data what I have. Okay, now what is the operation I am going to perform? I am going to perform RLA, that means rotate left accumulator. What does it mean? Rotate left accumulator. That means what is the thing that is going to happen? First of all, the left shift is going to be happen. Okay, how can we perform the left shift? First, initially, just to do it, is it 1 minute? Yeah, take this as an example. 1 00 11100. This is the example that we have taken. First of all, what is RLA means? Rotate left the accumulator. That means first is what is the first thing we have to do? We have to perform the left shift. We have to perform the left shift. Whenever I perform the left shift, what is the thing that is going to happen? See, left shift means the value that is present in the LSB, it is going to move to the next place. That means the 0 will come here and the next 0 not here, the 0 will come here. Then I have to print like this 0, next 0. Okay, then it is good for me to print like this 0 0 1 1 1 0 0. These two things. So this is what we will get, isn't it or not? Whenever I perform a normal left shift, Okay, this 0 will come here, this 0 will come here, this one here, this one will come here, this one will come here, and this 0 here, this 0 here. What about this one? Actually, if it is any left shift operation, this one will go to somewhere carry, okay, or somewhere where we don't know. But now what is the thing that is going to happen means, see, we are performing rotate left operation. So here if you observe, this 0 came here, this 0 came here, this one here, this one here, this one here, this 0 here, this 0 here. What about this one? Okay, this one is going to occupy the empty place. It is going to occupy the empty place. Where we have an empty place? This rightmost position now. So that one is going to occupy this particular position. So this is the order we are going to get. Okay. Now also if you perform any again RLA operation, what is the value we are going to get? What is the thing you will get? This is, we are going to miss this last bit 0. Okay. This is the bit that is going to be last, and all these bits are going to move here. That means what we are going to have? 0 1 1 1 0 0 1. Again here also we are having an empty LSB bit with which it is going to be filled. It is going to be filled with the bit that is escaped from the sequence. What is the value that is going to be missed from the sequence? This is MSB 0. This MSB 0 is going to be replaced here. That means that 0 will come here. So that's what they have given here with a diagrammatic explanation. What is the thing what he has mentioned? See, the value that is present in the 0th bit, it will move to the first bit. The value present in the first is going to be moved into the second. The value present in the second is going to be moved into the third. The value present in the third is going to be moved into the fourth. Fourth bit, fifth position. Fifth bit, sixth position. Sixth bit, seventh position. And the bit that is present in the seventh bit, it is going to travel all the distance in order to reach the LSB. That's what I have explained in your example. Okay, so this is about rotate right instruction. Clear? Okay, so we will stop here because I have to explain these 3 instructions. I will explain the next class somewhat briefly. Okay.